elements of the Java language done. It'll just be a few more weeks, and then I anticipate we'll have all the pieces of the puzzle complete. Something I would like you to start thinking about is that the last project, Project 4, will be a team project. So, the last project will be a team project, and teams are between 2 and 4 people, and there are no one-person teams. So, it's something you start thinking about. So if you're a loner, and you're like, I don't want to deal with other human beings, they're icky and gross, too bad. You have to deal with other human beings. So you may want to start thinking about, shush. You may want to start thinking about that, yes. Can you pick who's on your team? I am open to that, and I am currently talking to the TAs about it. My initial thought is yes, but it's not a guarantee yet because I got to make sure that we're dealing with all possible contingencies. But that is the way I would lean. All other things being equal, yes, I would let you pick your teams. So unless there's something that prevents us from doing that, then we will let you pick your teams, yes. Yes, go ahead.
Are you going to have a requirement on the number of people, aside from having at least 2 people?
The only requirements are it can be no fewer than 2 and no more than 4. So 2 to 4. Okay. 2 to 4 is the limitation. As long as you have between 2 and 4, you're good. That means there are 3 options, 2, 3, and 4. Not 5, not 1, not 7, the whole class. Not 32. 2, 3, or 4. It will be a game-based project. So, right now, unless something goes terribly wrong, it will be that you will be writing ghosts for a Pac-Man simulator. And it will be graphical, so we'll be able to see them move around and stuff like that. And your goal will be to kill Pac-Man. So.
That's awesome.
Yes, go ahead.
It sounds really hard.
It should be.
The question is, will you be writing the graphics? No, I'm not going to require you to write any graphics. There are some visual routines that will be provided to you that you can do, that you can draw stuff on the screen using. So if you want to do some drawing on the screen, you definitely can. And in fact, I would encourage it for debugging. But no, we're not going to be requiring you to do graphics programming. It will be visual, so you will be able to see what's happening on the screen in real time. I'm also forcing all of the TAs to do this project in teams of 4. And on the last day, after the final, we will watch their AI try to defeat Pac-Man. And they better be good, because otherwise we're going to laugh at them. They're going to be good, right, Manny? Yeah, I hope so too. So, okay. So all the TAs will be doing the project as well. You won't be alone. And I will release that as soon as I can. I want to make sure it's pretty polished first. I've done most of the work already for it. I'm going to keep building it out, and hopefully we'll have something pretty solid for you very, very soon.
We'll figure it out.
We anticipate. Oh, you have a question? Yes.
So, in reference to the final exam, when would that project be due?
Okay. So right now the plan is for the last project to be due on. Let's see. It's December 5th. The final exam is December 14th.
Jesus.
So that's the current plan. We're also planning on releasing the 3rd project on Friday, this Friday. That's our goal, is to release the 3rd project this Friday. So this Friday you'll get the 3rd project, and then a few weeks later we will hopefully release the 4th and final project that is the team project. Yes, go ahead.
What kind of material are we going to be working through for Project 3?
What type of material you're going to be working through in Project 3. In Project 3 is going to be focused on building a system of classes and objects. So it will also be a game-related project, but the main focus will be objects and using them and classes and stuff like that. The 4th project is focused on class inheritance, where you inherit from existing classes and use existing classes. Somebody else, I thought I saw a hand raised, but maybe I'm just seeing things. Yes, go ahead. Are there going to be office hours this Thursday? For the TAs, I don't know. You would have to look at the schedule on the syllabus. My office hours are all Wednesday, and currently they're all booked because people have already asked for appointments. But there should be a listing of TA office hours for Thursday. Oh, I'm sorry. My apologies. You're talking about because the crazy people are going to be here. That's a good question. I will get the TAs to, today I will message the TAs and tell them to have an answer for you. My guess is that most of them will be here, but there may be a few who feel uncomfortable. So sorry I don't have a straighter answer. I honestly haven't asked them. I probably should have. I'm a bad boss. So. Anyone else? Right. Is this really not coming up? It would help if I plugged the cable in. Okay. All right, so I'm a little behind. Story of my life, and probably everybody's. So I have not yet uploaded the lecture slides. I will upload them as soon as I get back to my office. So today, I don't even have pictures. That's how busy I've been. I didn't even have time to look up terrible clip art. But I do have a terrible quote. So today we're going to start talking about classes. So we've seen this word class before. We've talked a little bit about what classes are. Today we're going to dig into the details and see how we can actually build these classes. Oh, by the way, speaking of classes, did you guys know that you are the biggest programming fundamental class ever at UF? Also, why hasn't anybody dropped this class? I was expecting a 10% drop rate, and that has not happened.
I already heard like a bunch of people talking about dropping it.
As of right now, less than 1% of the class has dropped the class. So maybe that'll change. We'll see.
Yeah, a bunch of people are dropping.
The standard drop rate is somewhere around 10%. So yes, well, that's in the first 4 weeks usually 10% drop. So we're already beyond the curve. Yes, sir.
I just put on yourself when you said that programming requires grit, determination.
Oh yeah, well, it's terrible that I've convinced you to have grit and determination in this discipline. It's the most awful thing. That's why you're all sticking around. Okay. Well, if that's a cross that I must bear, then I will bear it. So, okay. The thing about classes is you probably have already realized what you've learned already pretty much technically would let you write almost any program, right? I mean, if you want to get into the nitty-gritty and the nuts and bolts, the tools you've learned up to this point about programming, you could write almost any program with what you know already, right? I mean, obviously you'd have to learn and you'd have to, stretch your abilities, but all the fundamental pieces of the puzzle are there. In fact, for decades, there was not even really any object-oriented programming. Classes came around and really came into heavy popularity across the board with the language C++, and then Java, of course, takes from C++. And the reason that classes took the world by storm is because they're a very effective organizational tool. They help us organize and manage and understand data. They help us abstract information. Strictly speaking, they are a human construct. They are a construct that, as human beings, we use to make code more understandable. And that's why I picked this quote from the book, The Structure and Interpretation of Computer Programs, that programs must be written for people to be read, and only incidentally for machines to execute. Because the way that we structure code is principally driven by the fact that other human beings must look at the work that we do and understand it. So keep that in mind. All the stuff we're going to cover from this point forward is conceptual in nature. I mean, we're going to learn the keywords, we're going to learn how to do it in Java, but all this stuff is conceptual in nature. Yes, sir?
Are we going to go over all the differences between object-oriented and functional programming?
The question was, are we going to cover the difference between object-oriented and functional programming? And it's a good idea, and I hadn't planned it, but we should. So I'll add that. I'll add that to the list of topics we cover. Okay, so what are classes? Well, the idea of a class is that we take a set of information, a set of attributes or variables, and we pair them with a set of functions, which we call methods, into an object. And an object is a collection of certain variables, certain information with certain methods, certain ways of acting on that information. A class is the design for that, right? A class says, here's how you build some type of object. So, let's say that we wanted to build, let's say we had a game where there were cute little monsters that you kept in little red and white balls and used to fight against one another, right? Let's say we had such a creation. We might have a class called monster, and it might have two variables in it. One that held the level of the monster, and another one that held a string that is its name. So, obviously, this is a little simplified, but you could probably think about how you can add additional variables to make this more interesting. So every monster has a name, and it has a level. And then we might have a method to change that level when we wanted to. A method set level that would let us take in some new level and reassign it. So this is the class. This is the design for how we would build monster objects. So how does this actually happen in practice? Well, let's say we have a program, and if we have a program, that means we have a heap and a stack. So we have this program called myProgram, because I know it's not a clever name, but if you can think of a better name, let me know. We have some main method, and of course we're going to have a stack for that. And let's say we have a monster variable that we'll call Pika, and we'll create a new monster variable, a new monster object, and point Pika at it. So here's what happens. When we create that new object, it's going to take these default values and it's going to create a new object. So we can have multiple monsters, right? I have Pika, but you could also have one called, oh, I don't know, Jigglypuff or something like that, right? Psyduck? Is that better?
Just call it instead of my program, I choose you.
I choose you, yeah, that's what I should call it. Okay, so we can have multiple monsters, and what's going to happen is that for every single one of them, it's going to allocate some data, it's going to allocate some space on the heap so that we can actually access that data. And initially, remember, strings are objects, so that means they're like arrows, they're references or pointers, and they point to some string. So in this case, it's going to start out pointing to, oh, I meant to change that. It should be some monster, but you get the idea. So that's how it starts out. Then maybe we change the name to Choo Choo, right? And that means that this variable pointer is going to get reassigned, and then we don't have access to that old string anymore. And then maybe we set the level. And when we execute the set level function, that's going to create a new stack frame. It's going to execute this set level method, right? So we do Pika.setLevel. So it's going to go into set level. The new level is 10. The old level is 0. And so it's going to change that 0 into a 10. That's this line right here. Okay, so that's the basic idea. You may also notice that I'm using these names, private and public. And we're going to get into more detail on that pretty shortly here. But the basic idea is anything that is private can only be accessed from within the class. It cannot be accessed from outside of the class. Anything that is public can be accessed from outside of the class. Okay, somebody had a question. Yes, we'll start here.
So does the object that you access private variables that it's not?
Let's see, you said, could you say that again?
Does the object let you access private variables that it's not?
Oh, the question was, does the object, if you have an object and you're inside a method in the object, can you access the private variables of another class? The answer to that is it depends on the class. It depends on the language. Generally, yes. Generally, yes, you can. That's not a universal thing. So, but in Java, you can. Does that answer your question? Yes, in the back.
On line 5 of my program, how's monster a variable?
Yeah.
Oh, line 5 right here. So monster is a type. This is a type. The variable name is Pika.
How is the type? Is it arbitrarily making a type?
Right, so that's what this is up here. Right up here, we created a new class called monster. When you define a class, you're basically defining a new data type. Does that make sense?
Oh, wait, can you repeat?
Yeah. Yeah, go ahead.
So a class can be a data type?
A class is a data type.
Declaring a new
It's not that it just can be; it is a data type.
So when we declare monster Pika, the public class monster, you can make one just for Pika itself?
Yes, so I'm going to rephrase your question, but it's a good one. So when we declare a new monster, what it's going to do is it's going to go back up to the class definition and create a new object from that class definition. And we can have lots of monster objects in this way. So I can have Pika equals new monster, and then I can have another one that could be Jigglypuff as a new monster, and I could have Psyduck as a new monster, and so on and so forth. Does that answer your question? Okay. Yes.
So how do you run both things at the same time? Because they're...
That's an excellent question. The question was, how do we run both things at the same time? And I'm actually going to answer that in a future slide, but if you can hold on for just a minute, just pretend that it just works for the moment, just because I don't want to get too complicated all at once. But yes, there is some extra magic we have to do, and I will show you exactly what that is. Yes? Yes, the question was, when I create a new monster variable, do they all have their own levels and their own names and everything else? And yes, they do. That's the power of classes, is that every time we create a new set of these variables. So we have Pika.level and we have Pika.name, but if we had another one, there would be two separate variables for each other monster that we have. Does that answer your question?
I hope you
Yes, go ahead.
I think I understand.
Oh, that's an excellent question. The question was, can we just declare this whole thing in one line? Why do we have to have 3 lines? And the answer is yes, we can. We haven't gotten to that yet, but we're going to. But we definitely can do that, and we're going to take a look at how exactly we can do that. Let's see. Yes, go ahead.
Why'd you write a function for set the level but not for set the name?
Oh, good question. The question was, how come I wrote a function for set level but not set name? And the answer is that actually the proper way to do it would be to have both, but I was going for brevity. In this case, I made the name public so I can access it without a function, but because the level is private, I can't get to it without a function, without a method. Because it can only be accessed from within the class. Because only the class can mess with private things. So like down here, if I did Pika.level, it wouldn't work because it's private.
Okay.
Does that make sense?
Yeah.
Anyone else? Yes, go ahead.
Okay, this is kind of it's more related to the actual main question, but how much code is required just to make, I don't know, the whole Pokemon?
Okay, so I'm going to answer this quickly. How much code is required to write a game like Pokemon? And the answer is hundreds of thousands, if not millions of lines of code. So, I mean, these are multi-million-dollar games for a reason. That's because they have to pay a bunch of people making about $70,000 a piece, a multi-year salary. So, yes, go ahead.
Do you have any idea what portion of that is reused code, like game engine and such?
Okay, this is the last game-related question I'm going to answer. So a lot of it's reused, but not all of it. So maybe, if you're lucky, maybe 40%. So, yes.
When setting class private, like, do anything that goes bad?
Oh, good question. So the question was, what if the class was private? Then what would happen? And the answer is that there's a couple of answers to this question. Because there's a couple of different ways you can build classes. If it was in its own file, you could never use it, so it would be pointless, right? So you shouldn't do that. You shouldn't define a private class inside of its own file all by itself. If you had a private class in the same file as another class, then anything in that file could use the class, but nobody else. If you have a private class, you can also have it inside of another class, kind of like class inception. Yeah, you can have a class within it. You can actually have a class within a class within it. You can do it if you want to. They're called nested classes. I mean, they're not common. You don't need to use them very often, but occasionally they do show up. And if you don't want anybody else to be able to access it, you can call them private. Does that answer your question? Yeah. But generally speaking, anything that you want to be widely usable, you're going to make public. Yes, go ahead.
When you're writing your code in your IDE, are all of your classes just going to be long columns, or will they be tabs?
The question was, if you have if you're like writing a bunch of classes, what's the normal way to define the classes? And the answer is every public class has to have its own file. That's a requirement in Java. So every public class must have its own file. For non-public classes, you're going to have them in the file with whatever is using them. But usually, yes, for every class that you might have 3 or 4 tabs open and be jumping between the different classes based on what you're working on. That's pretty common. I usually have 3 or 4 open at the same time. Yes?
So is the class just a way of organizing variables?
That's exactly what it is. The question was, is a class just a way of organizing functions and variables? And that's precisely what it is. A class is exactly a way to connect data with function and wrap it up in one giant package. Yes, and actually we're going to talk about keyword package soon, which is a real word in Java. So it's a real English word too, but I meant in Java. Okay, anyone else? Yes.
If you have a program with multiple classes, are variables shared with each class, or do you have to import variables into another class?
If you have them in different files, you mean? Like the classes in different files? Yes, so the question was, if you have classes in different files, how do you use them? And the answer is you use the import keyword, which we've been using up to this point, which is what you mentioned. And we're going to talk about that in detail shortly. But the short answer is yes, you use an import statement.
Oh.
Anyone else? Okay, this is pretty fundamental, so if you have any questions at all, now is the time to ask about classes. We're just going further down the rabbit hole from here. So, yes.
What are the rules for declaring the name of a new class?
Oh, what are the rules for declaring the name of a new class? So the short version is that a class name can be any previously unused identifier. Valid identifiers start with either an alpha character, an alphabetical character, or an underscore. In practice, we don't use the underscore unless we're doing like low-level like system stuff, because those are usually simple. That's usually what we use for that stuff, so we don't want to use it for anything public-facing. The convention is that you capitalize the name of a class in Java, and you do not capitalize the name of an instance. So you'll notice that I'm capitalizing the word monster, capital M, but I'm not capitalizing the variable Pika. Does that answer your question?
Yes.
Anyone else? All right, so once once we finish up the execution of a function, we're going to pull things off of the stack. Eventually, when the program finishes executing, the heap gets deallocated as well. So that's the basic idea of a class. But how do we actually use these in other places? And that's where packages come in. So the idea of packages, also known as modules, also known as namespaces, these are different in different languages. In C++ and in C#, they're called namespaces, but the concept is the same. They are a way to organize different types of classes and objects. So if you want to define that something is going to be inside of some package, then the first line of that class will say package and then whatever the package name is. So in this case, I'm defining the package to be monstermash.characters. And like this is an abbreviated version of the monster class. I have the 2 variables and then the rest of the stuff. I just put dots here, but we've seen the rest of it on the previous slide. I might also have another class for players, and it might also be in the package monstermash.characters, and I'll call it player in this case. So, and maybe it's very similar to the monster class. So I have 2 different classes here. And then in my program itself, if I want to access these 2 types, these 2 classes that are inside a package, I have to import. In this case, I'm importing everything in the package. So I do monstermash.characters. Asterisk means everything. That's what that means in most programming conventions. If you have an asterisk and it doesn't mean multiply, it means get everything. So, yes, sir.
So when you're, since you're importing the actual package from another file, if you move the file, you're going to have to readjust everything. So
Yes, so hold that thought for just a second, because I haven't talked about directory structure, but yes, the short answer is yes. Bring that up in a second. Yes.
What if I try importing asterisk dot asterisk?
What if I try importing asterisk dot asterisk? I actually don't know what would happen. Probably nothing good. We can test it though. You should test it on your computer. Yes. Can you import just a class? Absolutely. So if I wanted to, I could do import monstermash.characters.monster. So in this case, I imported everything in the package, but I could also import an individual class within a package. And I'll have an example of that on a future slide. Okay. One other piece of the puzzle is that all of these packages are not just names. They also depend upon a directory structure. So if your source directory, like in IntelliJ or another editor, is src, then inside of that, if you want to have a package, monstermash.characters, then you have to have a directory, a folder, called monstermash inside of your source folder. And then inside of that, you have to have another directory, another folder, called characters. And then inside of that nested folder, there is where you would have the monster and player Java files. So there's a connection in Java. This is not universal, but it is true in Java. There's a connection between the directory you place the source file in and the package of the class. So if I moved these files somewhere else, I would have to change the package name. And if you do this in IntelliJ, it's actually smart enough that it'll make all the changes for you. It'll ask you first usually, and then it'll actually make those changes. But that's something that's important to keep in mind. So my main program, that doesn't necessarily have to be in any particular package. I'm just going to put it in the root, the source folder, and call it my program.java. But this is the structure of this particular program in this case.
So in Java, it differentiates like folders with period instead of slashes.
Yes, in Java, the package, the nested packages are differentiated with periods rather than slashes. Yes, but they are reflected in the directory structure. Anyone else? Yes.
So when it comes to how you have the monster.java and the player.java, can you put them all in the thing? The first part you have them two separate things. Are you able to put one
Can I
under
put it in
here?
the same file?
Yeah.
Not for public classes. Public classes have to go in their own file.
Okay, so it's one.
Yeah. Public classes have to be in a separate file each. Yeah. In Java. Yes. How is this different from implementing classes? I mean, that is basically what we're doing. These are just different ways to organize the same information. Does that make sense? Anyone else? Okay, so these are this is how you do packages, this is how you build separate classes and bring them in. But we've really just scratched the surface. One big thing, one big deal, one big issue that we try to deal with object-oriented programming is that human beings, we make stupid mistakes, right? We make a lot of stupid mistakes, and anytime we can prevent ourselves from making stupid mistakes, we want to do that. One good way to prevent us from making stupid mistakes is to put some checks and balances on stupid decisions. So, for example, this is not true in Linux, but in Windows and Mac OS, if you try to delete everything on your drive, they'll say, "Are you sure you want to do this?" On Linux, it'll just be like, "Done," right? But on Windows and Mac, most of the time it'll be like, "Are you sure you want to destroy all of your information? Is that really a good idea?"
Yes, it is.
And sometimes you say yes, and then you cry afterwards when you realize that you made a mistake. Usually we have these kinds of checks to prevent ourselves from making mistakes. And the same thing is true in programming, even though as programmers, as developers, and computer scientists, we like to think of ourselves as brilliant and infallible and beyond reproach. We also make mistakes. I know it's hard to believe, but it's true. So we make mistakes, and access modifiers help us protect ourselves from making mistakes through a concept known as encapsulation. The idea of encapsulation is that we put limitations on what we expect to need to access in order to prevent ourselves from breaking things. So, for example, we talked about this class monster. Generally speaking, we almost always want our variables to be private in scope. In other words, we want them to be built in such a way that only the inside of the class can change those variables. Now, if we do make something public, like here I made the name string public, that means that anyone from outside can change it at any time. That means it's easier to make a mistake and actually change it. Now, you might think, that's silly. I mean, I'm not going to make that mistake, but when you're digging multiple levels down in 100,000 lines of code or 1 million lines of code, it's very easy to make a mistake. Basically, we have these access modifiers to limit the damage that we can do. There are 4 main access modifiers in Java. Well, there's 3 in the default. Private means only the class can access that data. It can only be accessed from within a class. If you have no modifier, that means it has what we call package access, which means any other class in the same package can modify it. So, for example, in the previous slide, I had the classes player and monster in the same package. They would be able to modify each other as far as anything that does not have a modifier. So that's the default. The default in Java is that packages can modify one another. Yes?
So we don't have to actually put down none in brackets, right?
Right, you do not have to put down none in brackets. That's just something that naturally happens, yes. Another keyword is protected access, which means that, and by the way, this is inclusive, so anybody at a higher level gets access to the stuff underneath. Protected, if something is protected, that means subclasses, derived classes, which we're going to talk about later, much later in the curriculum. But when we have one class and we inherit from another class, those subclasses can have access to any protected members. If it's protected, that means also the package can access it. And finally, we have public, which means anybody can access it at any time for any reason. So those are our basic access modifiers. The main ones, the one used most often, are private and public, but we do find uses for the others from time to time. Yes?
So, with public, it also can they also like crossover classes too? So, like, we call it call it a specific function.
Yes, so the question was, if it's public, does it cross over between classes? And the answer is yes. Public means anybody, anywhere can access it. Okay, so let's say, for example, that we had an instance of monster that we created called Pika. If we try to set the name, that'll work fine because that's public. But if we try to change the level, that is not going to work. That's going to fail, and it's going to be a compiler error. And I didn't include the sound of the baby crying this time, but hopefully you guys can remember it, right? Yeah. That was really terrible. I haven't had babies in a while, so it's been a while. So there we are. So it won't compile because we've tried to do something that violates the access level we set. So this is a way that we protect ourselves from making mistakes. Okay, anybody have any questions about the access modifiers? Yes?
So would it crash, or would it just pop out an error, or did you have to do like a try-catch?
The question was, would it crash or pop out an error? And the answer is it won't compile. Like if you try to run it, you'll get a syntax error. It'll say error like down in the box before it even tries to. It can't even build the program. It'll say error. You're trying to access a private member. You're not allowed to do that. Yeah. So it won't even let you even come close to running it.
Oh, okay.
Anyone else? Okay. We haven't taken a break yet today. Should we take a break? Let's take a 10-minute break. 7-minute break. 7-minute break. Please be back